Okay, so the next thing we're going to look at is a matrix. So a matrix is basically a two-dimensional array. So it's effectively rows and columns of values. So or it could be values, it could be strings, or it could be like booleans. But the point is, it's rows and columns. So this is very similar to basically like a two-dimensional like NumPy array if you're a Python user. Yep. So one thing with matrices is you have to have the same number of rows everything, all the values have to be the same type. So you can't have a mix of characters and numbers and stuff. They all have to be numbers or characters or booleans or whatever. Okay, so here's an example. So this matrix is being created using the matrix function. So we're taking the values 1 through 50 and we're placing them in a matrix that has 10 columns and 5 rows. And then we print it. Let's just run that before we do anything else. Okay, so there's our values. So we have 1 through 50, and you can see it has, again, 5 rows, 10 columns, and by default here it filled through the columns first. So 1 through 10 is column 1, 11 through 20 is column 2, so on and so forth. Note that you can also name columns and rows and whatnot in a data frame. So that's what I'm doing here, just to kind of show you how that works. So I'm creating a series of they're characters, A1 through C3, and I'm creating some row names, 1, 2, 3, and some column names, A, B, C, and then I use those vectors to create a matrix. So the values are defined by the data1 vector, then it's going to have 3 rows and 3 columns, so that should be a total of 9 values, which is what we have. By row equals true means it should go across the row instead of down the column as it fills the matrix. And then this dim names, wrapped inside of this list function, those are pulling the names, so we actually have names that we can use as opposed to the defaults, and then we just print it. So let's just run that whole block and then we'll look at it. Okay, so here's our result. So A1, B1, C1, A2, so on and so forth. So these are our values. These are the row names that the row and the column names that we defined, and they're filling across the rows as opposed to down the columns the way that we set it up. Just as a quick note, I'm just going to change something real quick. Let's do by row equals false and see what happens. So let's just rerun this. Should have ran it. Maybe it didn't. Let me see. Oh, sorry, it's up here in the markdown. I forgot. Yeah, so now you can see that the order is different, and that's because because I changed from by row to false, right? So now it's doing down the columns it's ordering them down the columns as opposed to across the rows. So anyway, if you make a matrix, just make sure it's being filled correctly, so you're matching everything up correctly. Let me change this back to true. There we go. Okay. Yeah, that's that. So indexing for matrices. So indexing for matrices is basically the same as in indexing for vectors, except now you have 2 dimensions, so you have to specify both dimensions, right? So in this example, we're basically going to pull out everything that's in row 1. Let me real quick just reinitiate this. That way, I don't know since I changed it. Okay, so this means row 1, all the values and all the columns that are in row 1. So when you do indexing for a matrix, what comes before the colon is the rows, and what comes after the column colon. What comes before the comma are the rows, and what comes after are the columns, right? So let's just print these and see if it makes sense. So basically, this should have subsetted out everything that was in row 1. So we go up here and we look at that. This is row 1, A1, B1, C1, and that's what we got. This should have been everything that was in column 1. So again, that should be A1, A2, A3, which we see here. And then this is everything, so row 1, but just in columns 2 and 3. So we got back, in this case, B1 and C1. And this is column 1 through 2, or sorry, row 1 through 2, column 1 through 2. So we should get back 4 values, and that's this. So A1, B1, A2, B2. So effectively that was these 4 cells in the matrix there. Here's an example where we have them unordered. So we're looking at row 1, column 1, and column 3. So this should return A1 and B2, or sorry, A1 and C1, right? Yeah, A1 and C1. And then here, now since we have names applied to the columns and the rows, we can also just use the names as opposed to the indexes. So here we're using row 1 and then columns A and B, which spits that out there. So that's one of the nice things about adding dimension names, is you can actually use those when you work with the indices.